With all of the examples that we've done so far, they've always given you the molarity or concentration of a chemical. But what if they didn't give you a molarity? You were basically shown how that solution was made, that they essentially give you a density. Then what would you do? Well, you need to convert that density into a molarity, then get the molarity of your ions rather than the whole chemical, and then your pH equations can kick in. So let's say we have an example like this guy. What if we wanted to create a solution of aqueous hydrochloric acid? And these were the supplies that I had. 2.5 grams worth of hydrochloric acid, and I have 750 milliliters of water. And let's say I take that acid and I put it into the water. Well, now it's no longer water. Wouldn't that turn it into an aqueous solution of hydrochloric acid, right? And hydrochloric acid is a strong acid, like all the ones that we are going to do any math for. And so we can assume it breaks up 100% into hydrogen ions and chloride ions. So let me take that density that I was provided. I have a mass and I have a volume. So let me put my mass on top, volume on the bottom. And I know it says 750 milliliters of water, but like we said, as soon as the acid touches the water, it's not water anymore, it's aqueous hydrochloric acid. So right now I have a density, grams per milliliter, and in order to use my pH equations, I need to switch that into a molarity instead. So I need my grams to turn into moles and my milliliters to turn into liters. It doesn't matter which step you do first, just as long as you do both steps. So because I want my grams to cancel out and go away, I need the molar mass of hydrochloric acid to cancel out those grams. So if you look at your periodic table and add together 1 hydrogen and 1 chlorine, you'll get a molar mass of roughly 36.5 grams per mole of hydrochloric acid. But my pH equations that I'm going to use in just a minute don't use molarities of chemicals. They use the molarities of the hydrogen or hydroxide ions. So I need to get the hydrogen ion. So I know from my balanced equation, for every 1 mole of hydrochloric acid, I would get 1 mole of hydrogen ions out of that. If I go to cancel out some units right now, I have the moles part of the molarity that I need. But right now I have moles per milliliter. I need moles per liter. So I need one more step. I know that there are 1,000 milliliters in a liter. I put the milliliters part on top because these milliliters way over here can cancel out with those milliliters way over there. And now the only units I have left, moles of hydrogen ions per liter. So my answer here, after you throw that in your calculator, would give you 0.0913 molar hydrogen ions. So if you know the molarity or H+, and this question is asking us to find the pH, you can find the pH by doing the negative log of your H+ concentration. If you do the negative log of 0.0913, you'll get a pH of approximately 1.04. Always a good idea to check your pHs and say, does this pH make sense for the chemical I'm being given? So HCl is an acid, so yeah, it should have a low pH. That's logical. Let's try one more.